Good morning, everyone. My name is Uri. Please take your seats. I'm really excited to be here, and I will tell you about it in a moment. But first of all, a few facts about me. So I am a Google developer expert for web technologies and Firebase and stuff, which means I go around the world in conferences and speak, share my passion to doing cool things with you, the nice developers around the world. I also love doing stuff with electronics and robotics and Internet of Things, as you will see in a moment. And some fun facts about me. So I dance salsa. Are there any salsa dancers in the audience? Just here. Anybody want to come on stage for a dance? Let's do it later. I also play the pan flute. So I brought it to you from Peru, my pan flute. I will play you something, and let's see if you can recognize this. In case you need some help. And today, we are not going to use any slides. It's all going to be like live coded and live fun. And before we start, I just want to tell you that I'm really excited because last month I got Polish citizenship, so I'm a citizen of Poland now. So Poland is now my second home, or as you say, dom. And as a web developer, dom is also my second home. So let's start with that. Oh, I forgot to mention one last thing. I also work for BlackBerry. Yes, they still exist. So with that, let's start for real. You heard about Angular Universal, right, this morning, and then you heard about the CLI. And now I'm going to show you how we are going to use those tools like Angular, the CLI, and some magic sauce to build a game. And I think most of us know this game. This is the Simon game, where you had a sequence of colors and you had to repeat them. And I built it for you with Angular 2. Using the CLI and everything. We're not going to build it from scratch because you already know about the CLI, but let me show you what the game looks like after I built it for you. So this is the NG Simon. Please meet the Angular 2 Simon. And let me put some sound here. Perfect. And as soon as I hit one of the buttons, it will start the game, and I have to remember the sequence that it shows to me and repeat. So I'm going to hit the red button. Let's make it a little less noisy. So you get the idea of the game. Also notice, when I start a game, it just flashes the light randomly. We'll use it in a moment. So you can see this game. It works in the browser. And before I'm going to show you how I take it out of the browser, let's do a quick review of how this game is built. So as I said before, I built it using the Angular, just started a CLI project, and created a couple of components. So what you can see here is actually the template for the main component of the game. And there are three important things to notice here. First of all, you can see that I'm using the Simon score. This is a component that I made, and this displays the score on the top of the game. Like when it says 0001, and it goes up whenever I go to the next move. And then you can see there are 4 Simon segments. Each of those segments is just a button of the game. So you have 4 buttons with 4 colors, like green, red, blue, and yellow. And finally, you can see, it's less important, but it's here, so let's mention it. There is the Simon blink, which shows this blinking click any color to start message. So this one. Do you remember in the days of Netscape Navigator when we had a blink element? So now I use Angular 2 to bring back this ancient technology to life. Thank you. So the reason they removed it is because not many people were excited about it, just like you. Now we don't have blink anymore. Anyway, so we have this score at the top. Then we have 4 Simon segments. And then we have this blink. Now, I'm not sure if many of you are familiar with debugging Angular 2, but there is a nice Chrome extension called Uri. I don't know how to pronounce it. Never mind. Anyway, you can access it from the Chrome DevTools. And the nice thing about Uri is that it can show you the structure of your application, just breaking it out down to component. So I can see here the Simon game component, which is the template that I just showed to you, the entire game area. And I can actually see here the components I just mentioned to you. So you can see there are 4 Simon segments, 1 per each button. And you can also see there is this Simon score. For some reason, it is displayed on the edge of the screen, but this is actually this play. And finally, you can see the not really important blink component. Let's see what happens if I click delete. No, it doesn't work here. I can delete it, sorry. And as you can see, we can also see the inputs and the outputs of those components in this extension. So just to make it more fun, let's change the color of the green button to purple. And it's now purple. Just like this is how we can easily debug Angular apps. But that's not why I'm showing it to you. I just want you to remember that each of those buttons, each of those segments, is a component that has color and the state, which can be true if it's like lighting right now, if it's on, or it can be null or undefined if it's off. So each of those is a Simon segment with state and color. And then we have the score component, which we can give any text to display, and it displays it in retro style. So let's give us 4,200 scores. Does anybody recognize this number? Yeah. What is that? The meaning of everything with 0, 0. That's actually amazing. I never thought that this was the reason they chose this port number for the Angular CLI. Thank you. You get a sticker from me. At the end of the talk, I will give you an Angular sticker. So to sum up, we have this game, 4 segments, and 1 score. And it works on browser. But add one more 0. OK. I will do it just for you, just to see that it breaks. OK, it works. Thank you. Somebody even claps for you. OK, so it works in the browser. But after I had this game working in a browser, I decided I wanted to try something new, to take Angular and extend the limits, get it out of the browser and bring it to the physical world. I mean, the game is nice on the browser. Let me just refresh to get the original one. It's nice on the browser, but it's not fun to play with a mouse or with a small smartphone display. I want the game real. And for that, let me introduce to you a small companion of mine that I use a lot in the past few months. It's called a Raspberry Pi. Have anybody here used the Raspberry Pi? A bunch of you. You're awesome. Very good. So I'm going to take out my Raspberry Pi. And as you will notice, it is actually connected to a bunch of stuff. And I know that not everybody can see it, so I'm going to take out the webcam so you can actually see it. And then I can tell you about this Raspberry Pi and what we are going to do with it today. So this is my webcam, just standard one. Connect it. And let's open the camera app. Wow, technology works. I love it. So yes, you can see it here. I will set up the angle for the camera real soon. The first thing I want you to know about Raspberry Pi, for those who don't know it, it's actually a small computer. And this Raspberry Pi can run Linux or Android or Windows 10. This is the size of the thing compared with my hand. But it's not fair comparison because my hand is closer to the camera. Yeah. So this thing costs $35. And we are going to see how we can run Angular on this thing and run the Simon game that we built for the browser on this thing for just $35. So it's a Linux computer with Wi-Fi and Bluetooth. And I'm going to connect it to power so we can actually see it. We can actually start running stuff on it. This is just an ordinary power bank that I have. And let's start up the Raspberry Pi. Now, since this is a live demo with hardware, everything can go wrong. I hope that it will actually work. It will take about a minute for the Raspberry Pi to boot. So while it's loading, I just wanted to mention that there are no slides for this talk, but there is a blog post I wrote about everything. So if you want and you have an Android phone, you can actually enable location and Bluetooth on your Android phone. And you may get a notification like a website was found for this location. I'm broadcasting a beacon to everybody here using a technology called the physical web. And this beacon contains the URL for the blog. So Android phone users, how many of them are here? Many. How many iPhone users? Also many. You know what? So iPhone users can also do it. If you got Chrome, you just open your notification center. You go to Edit at the bottom, and you simply add Chrome to the list of widgets. And then you will probably also get a notification. If you didn't get it, no worries. I will also post the link on Twitter soon. So while you are trying to get this beacon that I'm broadcasting here, let's see if I can already connect with my Raspberry Pi. Yeah, it worked. Perfect. So now I'm connected to my Raspberry Pi, logged in, and I'm going to just, I already checked out the project. It's already here, the same code that you saw in my VS Code. And the first thing I'm going to do is just run an npm task that will compile, using Webpack, will compile the code as we make changes so we can see the changes live. So this is Webpack running on this Raspberry Pi, $35 computer. And it's now ready. I'm going to open another tab and start the game. So let's go to ng2 Simon and start a game. Larger font. And you can see the game is running. And let me put a camera so you can see. Angular.2 is running. But nothing really happens. I mean, it doesn't work. Do you know why? Because there is no DOM here. It doesn't feel home here. We need to change the game. So instead of like working with a web browser, it will actually work with a physical hardware. Luckily, there is a library for that. A project I've been working on for the past few months called Angular.2 IoT. It's open on GitHub. And it gives us a set of directives, a set of components for Angular 2 that can actually communicate with physical hardware. And we are going to make a little amount of changes to the code so that it actually works on this Raspberry Pi. So what I'm going to show you now, we are going to open another terminal and change the code. So you remember we had those 4 buttons. Each of them was Simon segment. And what we are going to do now, we are going to edit the code for those Simon segments. So I'm going to vi src app Simon, and that's the segment component. And as you can see right now, the code is super simple. The entire template for this segment component is just an HTML button. This button can show the color. It gets the color from the input of the component, as we have seen when we debugged it. And it also emits click events whenever you click on the button. So the whole implementation is actually using an HTML button component. And what we are going to do now is to use Angular 2 IoT component to connect this Simon segment, this button, to the hardware. So we are going to use the IoT LED first, which will let us connect with those 4 LEDs that we see here. And you might notice that this Raspberry Pi has some pins on it, some metallic things we can connect to. I actually have a photo of it here, so you see there are like a lot of pins here. And there is a nice list of the names of those pins. Fortunately, we don't have to worry about it right now, because I already prepared, as we can see here, a mapping which tells us which LED color is connected to which pin. So all we need to do, we need to use the color that we got and select the right pin. So I'm going to say this IoT LED is connected with pin, and then we get the LEDs array index by color. And now I will be able to control the specific LED that is relevant for the color. And the second thing I need to do, I want to connect the state of this LED, whether it's on or off, with our state variable. So we get it from the outside, and we just pass it through to the LED. And now I'm going to close this component. And we can see that we just had to modify one of the display component, one of those 4 buttons. And I'm going to save it. It will take it a little time to build and restart. After all, it's not a super strong computer. And hopefully, by the time this app will reload in like 5 seconds, we'll see the LEDs going like flashing real quick. It worked, yeah! Wait. But you know what? We already connected the LEDs, but as you can guess, the buttons do nothing because we haven't connected them yet. Fortunately, with Angular 2 IoT, all we need to do is to add another small component, which is IoT-button. That's correct. So this button should use the same pattern. We already have the mapping for the pins, so we are going to say it's buttons indexed by color. And whenever it's clicked, you see it emits a click event, just like the real HTML button. And we call click.emit to send it to the Simon game component. And if everything works well now, let's see, pin and click, both wired. If everything works well now, I saved it. The game will reload in a few seconds. And I have the LEDs and the button wired to the game. And hopefully, I will actually be able to play the game. So which color should I start with? I see. Red. I heard red. Yes, it works. But you notice there is something missing. What is that? Like score? You said score first. You get score first. So yeah, I don't know how I'm going to display the score here. Let me check. Maybe I have something in my backpack. What is that? Oh, that's some sweets. You can come later and get some if you want. I can display it with those sleds, but finally I found that I actually have this nice 7-digit display that we can use for that. Let me just plug it into the circuit. I hope I don't burn anything while doing it. OK, and let's just connect it with the Raspberry Pi. Some wires are disconnected. Let's see if I can fix that. By the way, meanwhile, how many of you got the link to the blog that I posted with a notification on your phone? Wow, a bunch of you, cool. Like 40, 50 people, that's great. 41, perfect. Yes, so it's still running, and one more wire to connect here, and then it will hopefully show up something. And yes, so it's connected. It says hola, but if you remember from the actual game, it should say play. And you can see that whenever I click one of the buttons, the score doesn't really update, like nothing happens. And can you guess why? It's not connected, right? So we are going to connect it, because right now it's only displaying it to the HTML with this Simon score component. So we had this Simon score component here on top, and it's connected to HTML. It can even display extra zeros, as we checked before, but it's not connected with the hardware. So the next thing we are going to do, we are actually going to edit the that was the score component, and oh, it has a template in a different file. Yeah, and as you can see, it's just like a very simple HTML that displays the score that it got as the input. You remember before we changed the score and it changed on screen, so this is this score variable. And we are going to wire it to this 7-segment display. So we are going to use IoT 7-segment, and I think it's called value equals. You can notice that we are not displaying the score as it is. We are also adding 0. There is this 0 pad function that we call. So we are going to use it here as well. So we have always 4 digits and not like just 1 or 2. This is going to connect it, hopefully, if I don't misspell it, with the hardware. And I'm going to save it now. And if you can, if you remember, the actual game says play. So if everything will be fine, whenever the moment I save it, it will actually rerun the code and say play. Let's hold our fingers, and let me show you the screen. If it doesn't work, we'll probably get a long error here. So it reloaded. Yes, it said play. It worked. Thank you very much. So now we can actually play, and hopefully we'll also see the score when we play. Yes. It was green, right? Yeah, so now the game is almost complete, but as some of you have mentioned, we are still missing one major feature, which is sound, right? Green? Blink, yeah. So I will ask you to come onto stage and to say to everybody, like, please press any button to start a game, and you will do it with animation. That will be the blink. That's a good idea. Yeah, we're not going to implement the blink. There is a reason they removed it from the standard. It's annoying, but thank you for that. I think I owe you 2 stickers already, so come after and get them. And you can also get some sweets. I really love those. And there is sound. And luckily, I also found a little speaker in my backpack. And we are going to connect it with the Raspberry Pi. For this speaker, we are actually not going to do any code changes, because I already did it ahead of time. I'm just going to show you real quick what the code for this speaker integration looks like. So we are actually using a nice feature of Angular 2 called dependency injection in order to implement the sound differently on the web and on the Raspberry Pi. So you can see we have this abstract class. Did you know that you can do abstract classes in JavaScript, actually TypeScript? So go away. So we have this abstract class called synth service, which is a service that has 2 functions. One plays a tone. We can specify a frequency, and it plays a tone with that frequency. And another one plays a sound. We give it a name of a file, MP3 file, and it plays that sound. And we actually have one user of this synth service, which is this game component. If we go down to the template, the controller, there is a lot of logic. It's open on GitHub, so you can check it out later. But the important thing is that we inject here this synth service, and then this controller uses this synth service, like here, to play the tones of the game. So the important thing is that this game controller, this game component, doesn't really care about the implementation. It just uses these Simon segments and Simon's core, and as we have seen, we can easily adapt them to display the code to play the game on the real hardware. And it uses this synth service, as you can see here, to play the sounds. And this is the interface, the abstract class of the synth service, and there are actually 2 implementations. One is web synth. So the web synth actually implements it using the web audio API. How many of you have played with the web audio? Not many. So go and play with it. It's fun to play with it, like play the guitar or something. And then it implements play tone and play sounds using web audio. Unfortunately, I could not find a good implementation of web audio for Node, so I had to come up with another solution. And here you can see the Linux synth service, which uses Linux command line to play the tones. So there are 2 implementations of this service: the web synth, which uses web audio, and Linux synth, which uses Linux command line for playing the sounds. And if we look into the code that bootstraps, that creates the application, we can see that in the browser code, we tell the dependency injection, hey, whenever somebody asks for a synth service, use the web synth service. And in the IoT version, when we create the app, we say whenever somebody asks for the synth service, please use the Linux synth service. So we actually take advantage of Angular dependency injection to inject different implementations of the same service depending on the environment which we are running at. If you are more interested in learning more about that, there is a good blog post by Pascal Precht from ThoughtRam about dependency injection in Angular 2, really recommended. And now, after all this blah blah talk, let's see it in action. So I'm going to connect the speaker, and hopefully I will We will hear some sound here. That wasn't planned. OK, so the speaker is now connected. The code is already in, so we don't really have to wait for it to update. The game is waiting for us to play. Let me just take the camera a little backward so you can see it. And I'm going to play the game, hopefully with sound. So let's hold fingers to have some sound. Oh, I failed. Thank you. So we have seen that the game actually works. And before we are going to wrap up, I just want to answer a question that I usually get about this game. People tell me, OK, but why do you have to do it with Angular? Like, what is the advantage of using Angular on the Raspberry Pi and not running Python, for example? And there are several advantages. The first thing is I can create this game on my web browser, debug it there, make it work the way I want, and then just copy the code over to this platform, and it also works. So it's truly universal. I write the code once, and it works on both platforms. I have to write the unit tests once. If I make changes, I can test them in my browser, like the flashing LEDs. I added those this morning. I tested those in my browser. They worked. Then I just copied the code over, and it worked on the Raspberry Pi as well. So this is one advantage. And the second advantage is that we can use the big ecosystem that we have on NPM. So I didn't mention that before, but the code is actually also using Firebase. How many of you heard of Firebase? For those who don't, I wear a Firebase shirt, so you can learn about it here. Now you are more educated. So yeah, we have code that actually, that's inside a model directory, that actually writes the data into Firebase. And this works for the web version, but it also works for the IoT, for the physical version. And you can see this Firebase dashboard here. And you will notice that as I play the game, the data updates on the Firebase. Before we do that, let me just fulfill a promise that I gave you. I'm going to share the link on Twitter. So speaking, yeah, you will be able to find it in ngpoland.conf Twitter. And it's shared. Perfect. So going back to Firebase, you can actually see that as soon as I start playing the game, things are going to update here. Like, you can see it updates my score. Like, I have now 2. And it works like real time. But I don't like this dashboard, so I built my own dashboard for Firebase. And